Hello students, today we will start in the solid state continue the chapter electrical properties of metal. Okay, what kind of electrical property? There are three type of functions which is shown by any metal. What is conductor, insulators or semiconductors? You know what is conductors, which can flow current. Generally conductors we consider as a heat also, but only here we study the electrical properties. That's why we are only discuss about the current. Okay, what is conductor which can flow current? It's called conductor. Either it has a range of 10 raised to power 4 to 10 raised to power 7 ohm inverse, meter inverse. It is the range of conductor in the metals. They have conductivity in this way: ohm inverse, meter inverse. Okay, basically what kind of conductors? Metallic conductors, which you know, and electrolytic conductors. What is electrolytic? First of all, we will discuss the electrolytic conductors. What is electrolytic? Just suppose we are taking the example of NaCl. NaCl is the solid form, no conduction of electricity, but when it is aqueous solution, it is dissolved, it gives Na plus and Cl minus in the form of ion. And now they are free and they are moved, Na plus and Cl ions, to move to the flow of current and electricity. So what happened in electrolytic conductors? It is like NaCl example. In the ions form, they conduct electricity. You just know about this. That's why I am only written this. Free ions are reason for the move of for the reason of the conduction of current. Okay. What is metallic conductors which have a free electron? Today we will discuss regarding this. What is the reason? Electrolytic conductors, as you know, it is very easy. You have studied before. But electrolyte is free electrons, free ions are reason for the conduction of electricity. Today we will discuss regarding the free electrons of the metallic conductor. What do you understand by the free electrons? Where it comes from? Next point is valence shell electrons. Valence shell electrons take part in this. Okay? Sorry. Free electrons means valence shell electrons. What is valence shell? Suppose I am taking the example of this metal, any kind of metal, Fe. So outer shell electrons is called valence shell electrons. Outer shell electrons is called valence shell electrons. Metallic conductor in which free electron are the reason of the conduction of electricity. In this, valence shell electron take part in the conduction of electron, in the conduction of current. Just pause the video and note down these points. Okay. What happened with the conductors, which is a very important question for the range of conductor 10 raised to power 4. In the metallic conductor, already I am already only explaining the metals regarding not electrolytic. It is a metallic conductor range. Of what happened? Valence shell electron taking part in this conduction. Okay. Well, let me explain this. I am rubbing all this topic. Next. What happened in what way the current is flow? Look at over here very carefully. There is a two type of explanation is over here. It is called band theory. Band theory we are discussing today. What is band theory? There is a valence shell. Valence shell, as you know, and conduction band, and we can say this. Valence shell and conduction band, valence band. Sometimes it is called valence band and conduction band. Are you getting my point? Lower energy level in which electrons exist. It is like this. Generally, what happens in the conduction? They are in lower energy. It is called valence band. When electron move from this class to this class, it shows the conductivity. Valence shell to the conduction band, it shows the conductivity. Are you getting what I am trying to say? When the electrons are moved from valence shell to valence band to conduction band, they show the conductivity. Lower energy level, suppose 11th class is a valence shell, and conduction shell when you are going from the lower standard to higher standard. What happened in conductors? This band energy gap is very less. Suppose there is a criteria 100 out of 10 is passing. 100 out of 10 is passing. All the students can easily pass. Either he will do or she will do study or not, but they can pass. So the band gap is very less. That is called band gap. Energy band gap. You can write it in this way. It is called energy band gap. Are you getting my point? What is energy band gap? The distance between the valence band and conduction band. It is called band energy gap. Are you getting my point? I hope you will get it. Suppose I am giving the example in this way. Suppose you have to jump stairs. One stair anybody can move from this stairs. Suppose these are like this. Okay, just note down this thing. Okay, what happened? You have to jump from here to here. The band gap is very less. You can easily jump from here to here. So all the electrons can move. So all the metal atoms like iron, copper, are the metal level properties. They can easily conduct of electricity. Are you getting my point? I hope you are getting my point. We can easily move from here to here. Next step is very approachable. All the electrons, because 10% is very lower criteria. Anybody can go. What happened in insulators? Look at here. Look at over here. Insulators. The band gap is very high. The band gap this is valence band. This one is a conduction band. The band gap is very high. Suppose I have to jump from here to here. It is like this. I have to jump from here to here. It is very impossible. I cannot easily jump 4 stairs in one step. It is very hard. Only 1000 in a one student. Almost negligible. 1000 in a one student only can move. Suppose the criteria of passing is 90%. 90% and 95% is the criteria. How many students? Only very few students can move from lower band to lower energy level to higher energy level. Are you getting my point? What I am trying to say in this band gap, band energy gap is very more in this. So the electron cannot easily move from valence band to conduction band. Okay, so it shows the properties of insulators like carbon, like boron, like nitrogen, all are insulators. What happens in semiconductors? The band gap is average. Valence band between conduction band. What happened? The band gap. Suppose we have to jump from here to here. Only 2 stairs I have to jump. Those who are physically fit, they can move here to here very easily. So in the semiconductors, I have written all the range and also definition also. But what happened in the band gap is very average between the valence band. What is valence band? I have already explained to you. Lower energy level is called valence band, and higher energy level is called conduction band. The band gap is very average, so the electrons can easily flow from valence band to conduction band. Are you getting my point? What I am trying to say? Okay, so these are the 3 ranges. In the conductors, the band gap is very less. In the insulators, the band gap is very high. The semiconductor band gap is like silicon is the example of this. Silicon is the semi-metals. So some electron can move, so they can flow some electricity from valence band to conduction band. So in the insulators, never electricity can flow. Some electricity can flow, and full electricity can flow. Just make the diagram. This diagram is already in your textbook. Just pause the video and make the diagram very clearly. Okay, I hope you noted. Okay, next we have write down some definitions regarding this. Okay, next, what happened? Conductors, as you know, the band gap is very less. Okay, what happened in insulators? Write down regarding the insulators. In insulators, what happen? The band gap is very. The band gap is very high between valence band and conduction band. VB मतलब valence band and conduction band. So no electron can flow. Its range is 10 raised to power minus 20. You have to learn this range. 10 raised to power minus 20 to 10 raised to power minus 10 ohm inverse meter inverse. It is the range of this. Insulator which does not show conductivity. Here write on the one point also, which does not show conductivity. That are called insulators. And next one is semiconductors. They can flow some electricity. They can flow some electricity. The band gap is average. The band gap is average between valence band to conduction. So some electrons can flow. Write down the range, very important range. You have to learn the range of semiconductor. 10 raised to power minus 6 to 10 raised to power 4 ohm inverse meter inverse. For the MCQ question, this is very common question come in the MCQ. So please learn it very properly. Just pause the video and write down this point. Okay. Electrical properties, conductors, insulators and semiconductors. Now some student want to ask, conductors are already conductors, they are good conductor of electricity. Insulator cannot any flow of current. Lekin semiconductor, suppose I want to improve the strength of semiconductor. What should I do? Suppose I want to improve the strength of semiconductor, what should I do? One thing is temperature. What happened regarding the temperature? Suppose look at the over example over here. Burning incident regarding for that. Suppose what is the meaning of temperature? I am giving the heat. Suppose there is a fire in the building on the second floor. Nobody can in the normal cases nobody can jump from here to here. Suppose 10 students, those who are physically fit, can move from here to here. This floor to number 1 to number 3. Okay, but when the fire catches, everyone want to save its life because temperature is increasing. If they are not stopped over there, if they will stop over there, they will definitely die. So they can jump from 5th to 1 to save their life. It is like this. Suppose you are getting my point. आग लगी हुई है, तो basically they can move from any kind of place, from one place to another. Okay, so temperature increasing, then the electron of valence band easily can move a maximum. Suppose in the starting only 52 students can do valence band to conduction, but when giving the heat, temperature increases, they get the energy. 90 students can move from valence band to conduction band. So what happened? Conductivity will be increases. So here we can write by increasing temperature, the the valence band electron get energy. So maximum electrons can move from valence band to conduction. One method to increase the conductivity of semiconductors is called by increasing temperature, the conductivity will increase. Are you getting my point? And what is the another method? Another method is doping, but I will discuss in the another lecture. Today's class is over. Just do your study. Today's band theory is completed in the all the way. Just write down the notes and read your textbook carefully and prepare the notes. Thank you. All the best.